Hello everyone, myself is Kamble, working as Assistant Professor in Electrical Engineering Department at AISSMS Institute of Information Technology, Pune. Today we are going to see the topic Automatic Generation Control. In electrical power system, alternators, that is generators, are located in the power stations. These generators are producing electrical power, and this electrical power is delivered to the load centers with the help of a transmission lines. At load centers, the load which is available is not controllable, as we can't control the load conditions. So the load is not a constant load, that load is continuously varying, and due to variation in the load, there will be the change in the conditions of the voltage and frequency. That is, voltage value and frequency value will change according to the load conditions. So to control this voltage and frequency, we require some automatic control or control with help of some devices, so that we can change or we can maintain the constant value of voltage and frequency, and this maintain or keep the voltage and frequency value at a desired point, desired value, is known as automatic generation and control. So in both active power and reactive power demands, these reactive power demands and active power demands are not steady. They are continuously changed with the rising and falling trend. So there may be a increase in the reactive power, increase in the active power, as well as there is a decrease in the reactive power and active power. The steam input to the turbo generators, if it is a thermal power plant, the input will be the steam input. If the power plant is a hydropower plant, the water will be input to the hydro generators. So this input to the turbo generators, steam or water, must therefore be continuously regulated to match these active power demands, failing which the machine speed will vary with constant change in the frequency, which may be a highly undesirable. The maximum permissible change in the power frequency is plus or 0.5 Hz. In India, the power frequency is 50 Hz. So we will say that the change in the frequency will be, desirable change in frequency will be 49.5 to 50.5. If the frequency lies between these two limits, then there will be no effect on the load, or there will be no effect on the devices which are present on the load side. But if the frequency varies beyond these values, then there will be effect on the devices on the load side will get damaged. Also, the excitation of the generators must be continuously regulated to match the reactive power demand with reactive generation. Otherwise, the voltages at the various systems buses may get beyond the prescribed limit. The devices or the equipments which are used on the load side, each and every equipment will have some rated voltage value, and plus or minus 10% change in voltage is desirable. But if the voltage value goes beyond that desirable value, then that device will not work properly. So the voltage should be maintained between these desirable limits, desirable values, and with the help of excitation control, with the help of control of excitation of the generators, we can maintain the voltage at these desirable values. So in modern large interconnected systems, manual regulation is not feasible, and or we can't get a smooth regulation with the help of a manual control. So therefore, automatic generation and voltage regulation equipments are installed on at each generators. So this is a schematic diagram of load frequency and excitation voltage regulators of a turbo generators. If you see this diagram, so this is the generator. So this is the generator. This generator is coupled to the turbine. Let us say this is a steam power plant. So steam will be given as the input to the turbine. With the help of this steam will produce the mechanical power. This turbine is coupled with the generator. So output of the turbine, which is a mechanical power, that mechanical power will be fed as a input to the generator. As this is generator, mechanical in power will be input to the generator, and it is producing a three-phase electrical power. Let us say the three-phase electrical power is P plus JQ, where P is the active power and Q is the reactive power. While producing the electrical power, it is generated at certain frequency. That is, V is the frequency and F is the V is the voltage and F is the frequency. V is the voltage and F is the frequency, and this electrical power is given to the load sides. So this system is a schematic diagram of load frequency and excitation voltage regulators. So if you see this, V is the voltage which is produced by the generator. This voltage is given to a voltage comparator. This is a voltage sensor. The output of the voltage sensor is given to the excitation controller. This is the excitation controller, and excitation is given to the field winding of the generator. On the same way, the frequency which is generated by the generator, it is given to the frequency sensor and comparator. This is a frequency sensor and comparator. Output of this frequency sensor and comparator is given to the steam valve controller. Output of this steam valve controller is given to the steam. So these controllers, that is excitation controller and steam valve controller, are set for a particular operating condition, and these two controllers, excitation controller and steam controller, that take care of small changes in load demand without frequency and voltage exceeding to the prescribed limits. Just now I told you, that is frequency, there the plus or minus 0.5 hertz is desirable change in frequency. If the frequency goes beyond that, the devices on the load side will get damaged. Similarly, plus or minus 10% change in the voltage is also desirable. So these controller, excitation controller and steam controller, take care of maintaining the voltage and frequency at the desirable or prescribed limits. With the passage of time, as the change in the demand becomes large, the controllers must reset either manually or automatically. Small changes in the active power is dependent on machine angle delta and the dependent of bus voltage, while the bus voltage depend upon the machine excitation. Therefore, reactive power generation is independent of the machine angle delta. First of all, say how the frequency is controlled. So this is a frequency sensor. This senses the frequency of the output of the generator. It is connected to the load. Due to the changes in the load condition, there will be change in the active power. Due to change in the active power, there will be change in the frequency. Whatever the change in the frequency is there, this comparator compares this frequency, that is actual frequency, with the reference frequency. If this change increases, then it will give signal to the steam valve controller, that is to increase the output or increase the input to the turbine, that is steam input to the turbine will be increased or decreased. The output of the steam valve is controlled to this controller. So whatever the steam is given to the turbine will be controlled with the help of steam controller. Whenever the frequency increases, you have to decrease the input to the steam. Whenever the frequency decreases, you have to increase the steam input to the turbine. That is, due to increase or decrease of the steam to the turbine, the speed of the turbine will be controlled, and when the steam of the turbine is controlled, it will control the output of the turbine, means it is controlling the input of the generator, and when input of the generator is controlled, the frequency of the generator will be controlled. In similar manner, this is a voltage sensor and voltage comparator. A reference voltage value is given to this comparator. This sensor senses the actual value of the voltage. It compares with the reference value, and if the difference goes on increasing, then it gives signal to the excitation controller to increase or decrease the excitation. So with the help of this excitation control, this will control the excitation, and due to controlling the excitation, the voltage will be controlled. The small changes in the active power doesn't depend upon the machine angle, and this is independent of the bus voltage also. So when bus voltage is dependent on the machine excitation, that is, the bus voltage depends upon this machine excitation, that is, it depends upon the reactive power generation, and it doesn't depends upon the machine angle delta. So load frequency and excitation voltage controls are non-interactive for small changes and can be modeled and analyzed independently. That is, load frequency control is different, excitation voltage control is different. When we control the frequency, that time active power, you have to control the active power. When controlling the excitation means voltage, you are controlling the reactive power. So excitation voltage control is fast acting, in which the major time constant incurred is that of the generator field, when the power frequency control is slow acting, with the major time constant contributed by the turbine and the generator movement of inertia. Thus, the transients in excitation voltage control vanishes much faster and do not affect the dynamics of the power frequency control. So we are saying excitation control is a pure electrical control. So excitation voltage we are calling as a fast acting control. So due to controlling the excitation, the output voltage will be controlled smoothly. But when we are controlling the frequency, that controlling frequency means we have to control the rotation of the generator, and we are controlling the rotation of generator, the dynamics of power frequency dynamics, that is movement of inertia comes in the circuit. So transient in excitation voltage control vanishes much faster and do not affect the dynamics of the power frequency control. That is, frequency control and voltage control, these are the two different entities. Whenever you are doing the frequency control, you are controlling the active power. Whenever you are doing the excitation control, you are controlling the reactive power. So with the comparators, that is voltage comparators and frequency comparators, the smooth control of the active power and smooth control of reactive power is done. So this additional control devices are used in the power stations. So this system is called as a automatic generation and control.